This is no ordinary map. Each dot marks the location of hidden dangers lying just off the coast of Britain. Dangers that most of us had no idea even exist. From the deadly sea mines to the vast chemical dump sites, along with the staggering number of World War II shipwrecks. I didn't fully grasp the scale of what was going on here until I started to visualise it. And this is just what we know about. But how did Britain end up surrounded by these ticking time bombs? Why are they still here, and just how dangerous is the situation? I'll go through the map and try to answer these questions, reconstructing in 3D some of the most perilous locations, and explore the toxic legacy left behind, revealing the scale of the problem hidden beneath the waves, and hopefully reveal the full extent of the UK's sea mine problem. How many old bombs are there under the waters surrounding Britain right now? I mean, there's probably a lot left over from the war, but how many are there, and how many could still go off? When this idea first came to mind, I thought, there's probably a lot, but this was a way bigger problem than I imagined. The UK government claims there's over 500,000 unexploded ordnance, or UXO, surrounding the UK. And they can't just say sea mines, because they've occasionally done a crazy amount of dumping in the ocean, and a lot of that dumping happens to be weapons. And when I dug a little further, I discovered multiple maps detailing the known locations of hidden explosives, as well as chemical dumping sites just off the coast of the UK, like this map from an organisation called OrdTech. I wanted to take all of this information and plot it on my own 3D map, giving a different perspective on the problem. But before I get into the details of where we are today, I need to explain how we got here in the first place. This problem started over 100 years ago during World War I, when tens of thousands of sea mines started to be positioned at strategic points by both sides of the war, with the UK and the US laying a barrage of mines across the North Sea, blockading German vessels from leaving the area with 70,000 explosive mines, and up to 230,000 laid during the whole of World War I. They attempted to clear them up, but with so many mines it was difficult, and inevitably many washed ashore or were lost. World War II was a similar story, but with more complex mining technology. Mines were dropped from planes, thrown off of boats, and bubbled up from submarines. To counteract this, minesweeping methods were used. New ships built to deploy mines, new ships built to counteract mines, new experimental aircraft made to trigger mines using magnetic fields. The war just kept pushing the limits and incentivizing each side to create new tools to stop the other side from killing them, or at least scare the crap out of them, with multiple minefields and barrages still in place by the end of the war, and with the seemingly unrelated issue which had started to emerge at the same time: what to do with the stockpiling of chemical weapons, which I'll get into in a bit. But the mess of sea mines wasn't going anywhere easily either. The cleanup took a lot of time and resources, and being that this is the ocean, sometimes things don't stay exactly where you expect them to. Strong tides and storms displaced mines and either sank them, or they drifted off and landed on beaches. But sea mines were not the only explosives scattered across the seabed. So many ships had been sunk, aircraft had been shot down, and submarines had been, well, drowned, that now there were even more explosives that had entered the ocean. Here you can see the known locations of shipwrecks that took place during World War II. The blue dots represent the Allied ships and the red dots represent the Axis. As you can see, a lot of ships loaded with fuel and explosives were now at the bottom of the ocean, which brings us on to the issue that it creates today. Now, the ocean isn't just a place where we swim and play and have fun. Some people build things, and one of the things they like to build is wind turbines. Offshore wind farms are pretty popular. They enable us to generate energy without having to hear or see anything, which, surprisingly, not wanting to hear or see something becomes a common theme in this video. But in order to build wind farms, they now need to check for unexploded ordnance, which in turn adds huge cost. And those 500,000 items of UXO, according to the UK Parliament Committee's website, equates to 100,000 tons of explosives. And the cost to dispose of that is insanely high. Now, I wanted to know what this 500,000 items of UXO might look like. So, overlaying locations of UXO according to OSPAR munition report finds from OrdTech, we can see how some of that picture looks. Combining this with the known locations of dump sites leaves us with a picture of the current hazards around Britain's shores. If I add in all the shipwrecks from World War II containing all sorts of toxic materials, then we get this. But to fully comprehend what's going on here, I wanted to rebuild one of these UXO sites in 3D. I spent time researching what one of these UXO sites might look like, and found a few different images, but not many videos. I set to work modelling one of the typical sea mines used during World War II. I then constructed an underwater environment for it to sit in, and added some caustic lighting. I did think it was missing some details though, so I added a bit of algae, scattered a few munitions around, and a sunken wreck in the background. And the final render turned out like this. And to provide a little more context about some of the sea mines we're dealing with, some were originally moored, tethered to a line, and floating below the surface. Other mines sat on the seabed, and then there were also less common drifting mines. Now, looking over the map, you'll see these hazard triangles. They're here to mark historical munition dump sites. But what does historical munitions dump sites mean? It doesn't sound good. Not a net positive thing, more like I can't be bothered to deal with it, let's let the next lot figure out in a couple of decades kind of thing, which sadly has become the attitude of most of this situation. While researching the 500,000 explosives hidden underwater, I kept stumbling across articles about weapon dump sites, and I thought that it just doesn't seem possible. Then I found this.
And a special fleet handles the shiploads of surplus explosives. 30,000 tons a month go overboard, and if Davy Jones ever learns how to fire a gun, the mermaids had better look out.
I eventually discovered this map, created by the James Martin Centre for Non-Proliferation Studies. It marks global locations of underwater dumping spots, including chemical weapons. To quote them, since the end of the First World War, several countries have dumped at least 1.6 million tons of captured, damaged, obsolete or unwanted chemical weapons, agents and munitions into the world's oceans. One of the most infamous locations used by the British forces is Bjortford's Dyke, the largest British dump site. It's a 50-kilometre long underwater trench that naturally formed during the Ice Age glacial movements, sitting between Scotland and Northern Ireland, at around 200 to 300 metres deep. The location is confirmed to have over 1 million tonnes dumped there. 1 million! From 1945 to 1976, they dumped artillery shells and chemical weapons. They even dumped radioactive waste inside of metal drums encased in concrete from a laboratory. And although most of these weapons were defused, some were still live, with 4,500 having washed up on Scottish shores at one point, along with around 700 anti-tank grenades in more recent years, and one confirmed case of an explosion. Now, the resources I looked at break down that 1 million tonnes at Bjortford's Dyke differently, but all of them agree a confirmed 14,500 tonnes of 5-inch artillery rockets being filled with phosgene gas dumped there. But the group behind this global map for chemical weapons estimates some of that 1 million tonnes as the following: 330 tonnes of arsenic compounds, 1,890 tonnes of waste gases, 25,000 tonnes of nerve gas, and 120,000 tonnes of mustard and phosgene gas. I wanted to do a simulation filling up Bjortford's Dyke with all of these chemicals, but my computer struggled with over 1 million different objects. If we imagine 120,000 tonnes of mustard gas being in steel barrels, with each barrel weighing around 200 kg, that means you would need 600,000 barrels of mustard gas. But keep in mind that I've only seen one article claiming 120,000 tonnes of mustard gas. The UK Parliament's website states themselves that many records were destroyed after the disposal as a matter of routine, and luckily phosgene itself is destroyed in contact with seawater, which is one of the reasons the UK government deem it unnecessary to regularly monitor the site. However, mustard gas doesn't break down the same way in water, and radioactive material is documented there. The dumping that went on at Bjortford's Dyke is the main reason a bridge was never possible between Britain and Northern Ireland, since working just near the region is risky enough, as a lot of stuff was dumped there before it even made it to the dike. Laying pipes in that area has been suspected as the cause for dislodging munitions that end up on some of these beaches nearby. So why did they dump so much in the ocean? Why couldn't they find other ways of disposing dangerous materials? World War II is often described as the largest conflict in our history. The industrial scale of the manufacturing of war materials was beyond anything before it, and a lot of weapons would never be used, like the chemical weapons. Earlier I mentioned the stockpiling of chemical weapons that had taken place during the war. Well, this stockpiling had occurred because neither side was allowed to use the chemical weapon after an agreement made following the horrors of World War I. That and the difficulty to control them if the wind suddenly changed direction, although to caveat that, there are some cases of them being used in battle. But both sides couldn't afford not to build them in case the other side broke the agreement, which is why you probably saw photos of civilians wearing gas masks during the war. After the war ended, the Allies now had to deal with not only reducing their own huge surpluses of weapons, but also what to do with the enemy's stockpiles. The safest course of action, in their view, was to dump it. In the ocean, out of sight, out of mind. So they found the deepest spots and places far enough away that they wouldn't have to worry about it. Which, if you look over this map, you'll see that a lot of waters surrounding the North Sea are fairly shallow, marked by the lighter colour and ranging from a mean depth of 90 metres, with darker regions descending into hundreds to thousands of metres deep. Knowing this, armed forces chose the deepest and easiest spots to access. So this had me thinking, what does Bjortford's Dyke look like now? I tried to dig up footage, but I couldn't find anything publicly available. So like the UXO site, I wanted to visualise it, and used other sites as a reference. I got to work making my own visualisation of Bjortford's Dyke. I added phosgene shells and some steel containers for mustard gas, which in hindsight probably isn't exactly how they stored them, along with concrete blocks housing nuclear waste materials. It's quite deep there, so I changed the lighting from the UXO as if it was a torch attached to the camera. But Bjortford's Dyke is just one of the many dumping spots used post-1945. A lot of dumping wasn't documented, and official agreements weren't made up until the 70s. And even then, dumping still continued into the 90s, where agreements were strengthened. And I'll leave links below in case you wanted to explore either of these maps. I briefly mentioned that it would be insanely expensive to remove all of the man-made hazards found in the ocean. But there are operations in place to remove some of the UXO around Britain. Unfortunately, most often the safest and easiest way to dispose of hazardous UXO is to blow it up, which has extremely damaging effects on local marine wildlife. But luckily, there's been success and non-destructive removal of UXO in Scotland. An area known as Carl of Donness, a coastal point of northern Scotland, had at one point over 80 UXO in this one small region. Luckily, they developed a method for removing the explosive without blowing them up. Destroying them in that way would have a hugely negative impact on the local environment and potentially damage habitats up to 35 kilometers away, since the shockwave of an explosion can travel much further underwater and affect a lot more marine wildlife. The UK isn't the only country dealing with chemical dumping grounds. Places like Estonia have a big problem with it as well. It's an issue likely to leave a long-lasting effect, and at the moment one without a clear solution. If you found this video interesting, you might want to check out my fully animated video on the evolution of narco submarines, as it's also an ocean themed video. But the real story is the fact that they smuggled drugs from South America to Europe in homemade submarines built in the middle of the jungle. I go fairly in depth with this and ended up recreating the interior of a narco sub based on all the images I could find, along with creating models of each submarine and detailing how they changed. Anyway, follow for more videos and animations. I've got a bunch more on the way and we'll be posting them on the regular. Thanks.